G'day guys, welcome to part 1 of the Seagull Models Xtreme Decathlon build series. So this is something that I have been building up for a few months now. I've been slowly getting things here and there for this build. And I can tell you right now, guys, I have been looking forward to doing this. This airplane is going to be the biggest plane I've ever built to date. If you've been following the channel for quite a while, the last large plane that I did on this channel was the CY Models Edge 540. Now that was a large model. I had a RCGF 35cc engine in it, so to give you a bit of size comparison. However, this Decathlon dwarfs it, and yeah, it's going to be massive. So what we're going to do first is quickly look at the workbench, and we'll go from there. Alright guys, so as you can see here, this is going to be the workbench for however long. I want to make it very clear right now, guys, that this isn't going to be, I guess you could say, a fast build. I want to take my time building this. And as you can see, guys, this thing is so friggin' huge that it came in 2 boxes. The large box down here holds the fuselage and a lot of the components and hardware and so forth. This box here on top is what holds the wings and the vertical and horizontal stabilizers and so forth, and if I remember correctly, wing tubes and things like that. So this is on the box here. This is the the 2 designs. Now I was thinking of getting the green one, however, as you can see, it's the most common Decathlon scheme. It's usually red or blue with the stars on it. I wanted to do something different, and I've gone for the red one. And to give you an idea of this size of this model, it is 122-inch wingspan, or 10 foot for those playing at home, and it can take between a 60 and 85cc engine. So that gives you an idea of how big this thing is going to be. So what I'm going to do right now, guys, is I'm going to take the boxes off the bench and get the fuselage out, and we're going to continue from there with this video. Well guys, here it is out of the box. So what I've done is I've just taken the fuselage out of the box. Now also for a little, I guess you could say a little transparency here. When I got this a few weeks ago, I took it out of the box to make sure that everything was there for the kit, and just to make sure that nothing was damaged and so on and so forth, because I mean, it is a very, very expensive model just for the airframe itself, and I just wanted to make sure that everything was fine. So I have taken it out of had previously taken it out of the box just to make sure everything was fine. Same with the other box with the wings and so forth. So what I'll do is, what I'm going to do first of all is I'm going to go over with you what I will be putting into this model. So for the engine power, for the power plant, so the engine, for this kit, I will be using this RCGF 60cc engine. I have had this on the channel in a previous video. So in that previous video, this kit was what I bought this engine for. So it's been run for a bit, make sure it's running sweet and it's good. So I'll be using that engine in this build. For the receiver, I will be using a Spectrum AR10 410T, and this is a 10-channel power safe receiver, and it's comes with, so it's your main receiver, and it has 3 satellites. From what I understand, under here it has a altitude meter and so forth. It's full telemetry. Along with the receiver, I will be using the new-ish Spectrum Synapse gyro system. It's AS3X Plus. So I could have got, there's another one of these receivers that are 10-channel, but it's not compatible with the Synapse gyro. So that's why I chose this particular receiver. For the control surfaces, I will, because this model, it has flaps, it has like ailerons, flaps, and obviously elevator and rudder, but each control surface requires its own servo. So there are so there are 7 servos, that's right. So for the control surfaces, I will be using these OMG servos. Now, these servos here, give me a quick second if I can get it out of the little sleeve here. So they are OMG A335 servos. These servos are digital, they are high voltage, they are brushless, and they have a 35 kilo torque spec at 8.4 volts. They come with an aluminium or aluminum, for American viewers, an aluminium servo horn. So I will be using these for the control surfaces, so all throughout. And for throttle duties, doesn't need to be anything fancy, but for throttle duties, I will be using this high-tech HS430BH servo. It's just a standard high voltage servo. It's only 5 kilo, but all that's going to be doing is operating the throttle on the engine. To power the electronics, I will be using 2 dualsky 5400 milliamp hour LiPo receiver packs. Given the size of this model and the fact that I will be using 7 of these OMG servos, I do not want any voltage sag or brownouts or anything like that. So I will be using 2 of these LiPo batteries. Some might think that they're a bit overkill. Better to have it and not need it than to need it and not have it, as they say. These are actually pretty good. They have an internal voltage meter, so if I push the button here, you can see as I push the button, it tells you the voltage. So at the moment it's at 50% charge, which means they're at storage charge. So I will be using those for to power the electronics. So what I'm going to do now, guys, is I'm just going to put these aside and we'll continue on with what I intend to do in this video. Alright, so with any new aircraft build that I do, there's a couple of things I like to do before I really get into this build. So in this video, part 1 is really going to be an introduction and kind of the start of what I'm going to be doing. So with any new build, especially with a kit that is an ARF like this, regardless of its size, whether it's a large scale Decathlon or something like a trainer aircraft, I always like to go over it and check to make sure that there weren't any, I guess you could say, bits skipped or missed, because I'm not saying that it happens all the time, but we as humans are imperfect, and sometimes we might forget something or not do something, and that's why I make it a habit to go over the model. And while I might not do it on camera, I will also do the same with the wings. And the reason why I always go over this is, like I said, sometimes someone might miss something. And what I might do, I might just use my phone, just so we can have a little bit of extra light. So the reason why I check over things is because, and I've been doing this before this little incident happened, but one of the members of my local RC aircraft club spent months building a model. It was a nice Tiger Moth, large scale model like this. Spent months doing it, working on all the details, and I was there for the maiden flight, and as he took off, the model started to roll to the right, and it just started going in circles. Never mind, that was just something moving on the table. And yeah, started rolling to the right and just started going in circles, and he was doing his utmost to correct it, and unfortunately the model crashed into the ground. And what happened was the servo mount in the wing wasn't glued properly from the factory, and as the model started gaining airspeed, the pressure from the wind obviously put force on the aileron, which put force on the servo, which caused the servo to break free from the servo mount. So that is why I always go through the model and I will check things, and like the wings, and I will be doing the same with the wings regarding the servo mount, but going over, looking at where parts have been glued, and as you can see around the motor plate area and parts leading up to it, they've used plenty of glue. And when I'm going to try and do this, there we go. So things like where it joins here, do we just pull on it, check it, see if there's any movement, which there's not. And same goes for up the top here. Is there any, is there anything loose? So I put the camera here, so we check things like up the top here, see if there's anything loose, see if anything moves, and that is what I like to do. And as I said, I will do this with the wings as well. I will do this off camera, and that is what I like to start off with a new build. So what I'm going to do is I'm going to pause here, and I will be back afterwards, and I will continue on with the next process. All right, so one of the next things I like to do in the start of a build before, so like I've gone through the model, through the fuselage, I've gone through the wings and the stabilizers and so forth, so and made sure that they're fine and there's no issues with the build or anything that may need to be repaired or remedied or anything like that. Once I've done that, what I like to do next is to go through my main electronics here and other miscellaneous to see where I'm going to put it into the fuselage. So obviously things like servos aren't really necessary, because obviously they can only go in one designated spot because of what they're intended for. So like your flaps and aileron servos and elevator servos and so forth, they can only go in one spot on the fuselage. However, when it comes to like the receiver batteries and things like the fuel tank here, I like to just go over things and and have a rough idea where I'm going to put it and how I'm going to go about it, because one of the things when you build a model is where you put things affects the weight of the balance of a model. And most aircraft are either nose heavy or tail heavy, and you may need to add weight to the front or to the rear or move things around. So one of the things, not only that, we go down here, as you can see, this will be the area where the electronics are mounted, and I like to just have a look and see where things will go and how I will go about mounting it. So as we can see here on this Spectrum receiver here, we have our servo ports here. We have the battery plugs area here, and then here we have the plug areas where we will plug in the satellite receivers. And then here we have, in this little corner here, where the Synapse gyro system will go. And not only that too, this receiver has a USB-C port for if you want to update it. So what I would like to do is just go put it in certain areas just to see where it would go. So for instance, we might just put it there for the time being, because see, we have openings here, and we might, and also with this model it comes with a lighting kit. So we have the lighting module that will plug into a separate battery, so we'll put that there for the moment. And how I intend to use the lighting system is through a switch on the radio. So I have here a remote switch. I was going to use one of those RCXL switches, however they're basically limited to 6 volts, and the lighting system operates on 12 volts, so I can't really use it. So I've got this little switch here, and it takes apparently up to 30 volts, so that is more than adequate. So want to figure out where we'll put that. And also with the receiver, it has this switch. It has 2 switches, so we have one there, but we also have this switch here on a nice long lead, and I might, for instance, end up putting it inboard up here maybe, or here. So we'll just put that there for the moment. Now we have the fuel tank. I'll put that in because obviously the fuel tank will go here, up in there like so. Now looking at it, I don't know if it comes with the kit, but I may have to 3D print a mount for it to line up with the hole. So we'll worry about that later. So now I want to figure out whereabouts I'm going to put the receiver batteries. And not only that, I have these plugs here, because with the Spectrum receiver it has IC3 connectors, whereas these dual sky batteries are XT60. So fortunately the receiver comes with plugs, like extra plugs, so if you choose not to use Spectrum batteries, it comes with plugs, so you can either solder the plugs onto the battery, or you can do what I'm going to do and have wires running underneath this tray here, and these plugs here will end up being mounted somewhere here out of the way, so I can plug it in, unplug it and plug it and so forth, so I can charge. So give me a quick second guys, because the battery on my GoPro is about to go flat, and I'll be back in a split second. Alrighty guys, so I have a rough idea, I think, of where I want my electronics to go, well, the main electronics in here. So I am thinking of having the power switch here, maybe, or maybe even having something, might 3D print something and have a little bracket for it here, so that way I can open the door and turn it off. I think too, what I'm going to do is 3D print a mount or a tray of some sort for the receiver batteries, and right here I can just move this, I'll just move this out of the way. So as you can see here, this is the battery plugs. I just got them balanced in here at the moment. I'm thinking they can go right there, they look like a good fit. Yeah, so I'm thinking there. And the other thing I need to take into account is the synapse. So given the size of it, I am thinking, and given the fact that because I have here, I've just put the throttle servo and servo block in, just mocked it up where it's supposed to go regarding the instructions. It's going to go, so it goes there, and I'm thinking having I was going to have the receiver batteries more over here, out of the way. However, I kind of want the weight to be more central, so I'm thinking right here behind the fuel tank. I looked at the instructions and it doesn't say anything about lifting the tank up, but I'm thinking I will make something to lift the tank up so it's more in line with the engine and the engine's carburetor, so I don't have any fuel issues. And I'm think what I might do too is, there's this big hole right here. I'm going to more than likely fill something in, fill it in with maybe a bit of wood, just so, and have the receiver a little bit more off to the side here, so it's out of the way. So that's really what I intend to do at the moment. I still might move things around. I have the lighting module back here. It might go back there, I don't know. So this is the first stage of the process. Now, if you can hear a funny noise in the background, one of the things I will be doing, well, I am doing, I should say, is if we go back here, I have the first two servos on my servo tester. What I'm doing is, it probably sounds really loud because it's probably resonating through this plastic table, but what I'm doing is I am running these servos, and I've got it set on auto so it does like a cycle. And the idea is that if I'm going to have a servo fail, I will want it to fail now. So what I'm doing is each servo will go for about 30 minutes, and then I'll get the next two servos 30 minutes, and so on and so forth. So, and the idea is, like I said, it's better to have the servo fail now than in flight. So that's something I'm doing as well. So got 2 servos down, 6 more to go. So that's going to be, really guys, that's going to be the end of part 1. It's not really eventful, but like I said, this is just the first phase of the build, just getting everything ready, inspecting everything, making sure that it's working fine, and making sure that there's nothing wrong. So that is the end of this video, guys. I hope you've enjoyed it. I hope if you have any comments, don't hesitate to drop a comment down below. And part 2, well, part 2 will be coming along as well in the not too distant future. Like I said, this isn't going to be a fast build. I'm going to take my time with it. But until then, guys, enjoy your hobby and cheers.